There's something new from our sponsor, Text Control. For decades, TX Text Control's rendering was tied to Windows functionality. But now it's a new era. TX Text Control is platform independent. You can run your .NET applications on Windows or Linux, deploy with Docker containers, Kubernetes, or host directly in Azure App Services. Seamlessly integrate document editing, signing, collaboration, and PDF processing into your ASP.NET Core and Angular applications. Are you ready to see it in action? Check out the live demo at demos.textcontrol.com. That's demos.textcontrol.com. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today, I'm chatting with Louis Beaudoin from ShareGate. He's a principal software engineer, and he works on ShareGate by WorkLeap. How are you, sir?
I'm doing fine, and you?
I'm very well. I was a little ill earlier this week, but I'm feeling much better. Coincidence here, I did not realize when I invited you on the show that we had one of your coworkers on a couple of weeks ago talking about .NET Aspire. That's such a small world.
Yes, it was a great episode with Anthony, who's our one of our staff developers here, who's working on our internal development platform. So he's building a lot of tooling that actually accelerate how we build software at WorkLeap for all the products. He's been a very important part of the team. He was working on ShareGate before, then moved to that central team. It's great stuff.
So he works on internal tools that are enabling you all to make the public-facing tools like ShareGate. Is that correct?
Yep, exactly.
Now, ShareGate is a migration tool. It lets you, migrate to and from Microsoft 365. Like I have Google Suite, and maybe I could migrate from Google over to M365. But when I hear about something like a migration, I got to be honest with you, and I know it's bad to say, I think, oh well, this is just some file copies. Like, do people minimize the complexity of a migration like I just did?
I'd say so, yeah. So doing a migration is a lot more complex than it seems, simply because, well, for a couple of reasons why. You don't own the data. So you take data, you don't know what to expect. You kind of dig around the customer's environment. There might be 1,000 documents. There might be 1,000,000 documents. There might be weird settings here and there. And then you need to figure out, okay, well, how do I bring stuff over in the more efficient manner, right? From the source to the destination. And then, of course, there are multiple different sources, providers, as you said, Google, SharePoint, Microsoft, Exchange for emails. And then destination is kind of the same thing. You're going to have different behaviors or different capabilities on each of those environments. So you have to balance it all out and find a way to how to move a lot of data in an efficient manner.
Yeah, I think it starts out very, like, if I look at it very naively, I'm thinking, how hard can this be? It's just a for loop. But then it becomes multiple nested for loops asynchronously over a long period of time, I'm sure some of these take days or weeks, depending on how much data there is. You have all the people, all of their documents, all of the documents' permissions. And like you said, it could be a million Word documents or one giant, gigabyte-sized video file and everything in between. And that gets complicated fast.
In both those cases, we'll use different, potentially different requests, different calls, different APIs, because sometimes, for example, you're talking about a big file. Well, you don't want to stream this, from the source to the destination by going through your memory on the machine, right? Because you're gonna hit it probably out of memory or dump on the file system, and it's gonna be, it's going to take a long time. So you have to find a way to take the data from the source and just stream it directly to the destination as much as possible. But then it gets complicated because sometimes you just, you need to transform some things here and there. You need to encrypt data. You're going to Azure, you're going to Microsoft. And you have to deal with what you have on hand in terms of APIs and what they're offering.
Yeah, and then there's on-prem to the cloud, there's cloud to cloud, and everything in between. I know some companies have hybrid situations as well.
Yeah, and they all behave differently. If you look at on-prem, the APIs from 2003, 2007 are not the same as 2010, right?
Oh
2010
no.
introduces CSOM, and it really helped us in our job to actually, we're now able to see some of the client-side object model, which is like the official SDK for SharePoint, for those who are less familiar with that ecosystem. But then, as things went on, CSOM is less present than it is now because we have better alternatives now with Microsoft Graph and better standardized APIs.
Oh wow, I didn't even think about that. There's 20 years of history here because like I know for example, I've worked on SharePoint like 20 years ago and it was calm and it was scary and then there was some soap in the middle somewhere and there was some rest. So there's APIs changing over decades, client side and server side. But then I'm on Google Suite for my personal stuff. I don't even know what their APIs look like. It's probably a hybrid mess of REST APIs.
It's still it's not that bad actually. It's kind of well documented.
Oh,
You
that's cool.
still just you still have some good ways to do some things, but there are some APIs that are out there and that they don't move much. They kind of they're not stale, but they work as is, so they're not changing, and that's okay. It's simpler for us actually to not have to update frequently certain parts of the code, right? Um, but then you always want to find if there's a better way to do it and improve, and then it's going to depend: is that API actually good? And just for to go back to the Microsoft ecosystem with Graph, like Graph is basically a facade over everything in Microsoft 365, and it's really helpful for us to have one way to authenticate, to consent, to uh, a standard to make calls, a good SDK that we can rely on. Um, but sometimes there are some blind spots in Graph where you simply cannot do certain things, or you can do it, but you need to combine different calls. And sometimes you have to, okay, well, I need to find an alternative because what is available is not what I expect or what I need exactly. So then you start to dig in, okay, well, legacy APIs. Earlier you were talking about SOAP calls. Well, we still have a few of them because there's no better alternative. There are some DLLs in SharePoint that are exposed that sometimes, oh, well, it's better to use that way because it allows to do certain things. CSOM is still a good way to work, even though we prefer Graph over some things. But you have a kind of a list of you should do this first. If it's not available, then this, then this, and this for Microsoft 365. But everything on-prem is still using those legacy APIs, if you will. Also, so we need to keep a diverse experience on these.
Yeah. I this is just I was actually talking to a friend of mine a couple of days ago about Microsoft Graph being one of the smartest things that Microsoft 365 ever did. Like I don't think people understand the work involved in unifying an API across so many things. Like people say like what are the interesting things Microsoft does and they talk about quantum and the cloud and all this kind of, but like from a business person's perspective, Graph is huge and I feel like it's almost 10 years old now and people don't realize how good it is, especially and just to look at the Graph Explorer and see how big it is and what you can accomplish. When that came out, that must have been really exciting for the product and the things that you were building.
Absolutely. Just like I said, like having to only one way to authenticate, not having to figure out on a non-documented API how do you interact with, is it with like a cookie or things like this, and one way to consent, one way to use, just it's so much simpler and good documentation on top of that. That's really important. As I said, like a lot of the SOAP APIs or even like CSOM weren't documented that much. So just this makes a big difference when you want to figure out, okay, how can I do something? And you don't have to spend a day trying to code something that might or might not work. You can look at the documentation and figure out, okay, I can do this and connect to that and then, build something on top. Then it's really good.
When you're migrating from one place to another, this might be a silly question, but I feel like the no one wrote the APIs to expect them to be called in the ways that you wanted to be called. I think when they wrote them, they expected one user to make a few calls to ask a few questions about a file. And I wonder if these things fall over when you call them hundreds, millions of times quickly in succession.
Yeah, it's really when looking at, for example, a migration, it's really a high volume scenario where um, you're repeating the kind of the same process for at different levels or different scope, if you will, right? You're okay at the site level. What do I need to do? Then at each library or list level, what do I need to do? And then up to the file, up to the version, and so on. So, for each call that you make, you need to really be fine tuned and careful about what you do, because let's say for a single file or even a version of a file, let's say you need to make 10 calls to copy it, for example. I don't have the exact number, but let's say it's 10 calls, and then you need to add an additional feature that requires an additional call. Well, repeating it a million times will have an impact on performance, on expectations with customers, but also you might trigger rate limiting or throttling, if you will. And then I like to use the imagery of having a call wrongfully placed, if you will, is a bit like having a car at front of traffic that's putting on the brakes for no reason. Like, it might slow it down for a second, this car, but the one in the back will have all the ripple effect, and then it might take an hour more simply because you wanted to do something, and then that call isn't necessary. So you have to really be careful about how you coordinate, and not only and really build around the critical resource. So the limits are not necessarily the same across different services in Microsoft, for example, or Google, or so on. So when you interact with SharePoint, you might have a shared limit of what you can call at one time, while if you look at Exchange, for example, well, the limit is built differently. It's per mailbox. Okay, well, then you can decide how to parallelize work differently because of those limits that are built differently. So it's really a question of orchestrating properly because you're going to do tens of thousands or even more calls in a really short time. So you have to get the most of it.
Are those limits published or are they discovered?
The ones for Graph are documented. Are they all enforced exactly as they're said? Maybe not, but and some are shared between at the per application, like in general across. But for other things, you just need to react. So and one colleague was telling me this a few weeks ago, and I found it really insightful. Is that how chaos engineering kind of became big a few years ago.
Mm-hmm.
And it really is a question of how you build fault tolerance properly. Well, a lot of it how we build software is really focused around how we react to fault tolerance. Not only from rate limiting perspective, absolutely, because then, okay, well, what you want to do right now might not happen right now because you're going to get, you need to retry later because you exceeded the limits. So you have to find a way to, okay, well, I'll wait, but then you have to think, is it the right time to block that thread and just wait, or should I do something else in the meantime? So that is also something to consider.
That is really interesting from a software architecture perspective, because I'm trying in my mind to architect this, and I know it won't be possible because this is the accomplishment of many, many, many years. But philosophically, when you're designing this, you could design it in a way that it simply reacts and adjusts, and you make an entirely adaptive system with zero knobs, zero configuration, nothing. It figures out the right number of threads. It figures out the right number of asynchrony, and it tries to adapt and be very, very squishy. Or you could have infinite configurable knobs and give administrators a huge amount of work and choices, and they could decide to start with 10 threads and then go to 100 threads, et cetera, et cetera, et cetera, because you just don't know what you're going to get. I'm curious which direction you all took.
We actually do offer a way to configure the number of threads you actually run, because it's for a few reasons. Because sometimes we cannot determine necessarily how close to the limit we are before hitting rate limiting. So sometimes we don't know exactly what's happening on your tenant. And you might not only encounter 429s, so too many retries. You might also encounter 503s sometimes that are rate limiting because basically the server is telling you, I'm on fire, so please stop, like, and in that scenario where, well, you cannot know that you're gonna hit it. So it's a bit more complicated. So having that kind of, we have a performance slider in our app, for example, that actually drives the number of threads and then requests we do in parallel logically. And that was useful for rate limiting, but it was actually introduced before because traditionally on-prem environment, and even before back in the day when Office 365 started, there was no rate limiting. It wasn't really enforced. So the idea was, okay, well, some people will actually make too many calls and then their environment is going to crash in a way, especially on-prem where you don't know the configuration of people, you don't know how good the machine is or machines that are running the environment. And then before telling you that it's going to, be on fire, it's actually on fire before you know it. So you need to actually have people, okay, well, you can gauge and maybe slow it down because your server is not responding quick enough. And it's actually hurting your overall performance because the server is not able to answer respond quickly enough.
That whole server on fire thing, it might make you chuckle, but there is a real difference between how cloud services behave and how Exchange on-prem works. Like Exchange on-prem is big iron in a room somewhere, and it has nothing in front of it. There's no Azure front door. There's no CDN. It's just you talking to an IP address, talking to a box, and that box will happily reply until 100% CPU, and then it'll start awkwardly hiccuping and stuttering, and then it's going to start throwing errors. And then you have to decide, do I back off? And like you said, a 429 is a very graceful, you need to relax, just tap the brakes, and then you get the ripple effect. But a 500 or 503 is like, stop talking to me, I can't concentrate, and then maybe a car crash is coming. And that's such an interesting and different perspective on how on-prem works than how the cloud works, which usually should be more graceful than that. Yeah
in general it is a lot more. We tend to see 429s before 503s, but you never know. Since I was talking about fault tolerance, you still need to cover for both just in case. That's the kind of mentality you need to have, and that's always when you rely on an external system that you don't have control over, right? So you have to deal with how it behaves and what's happening there, and you don't have a choice.
Yeah, it seems like there's the rate limiting and the efficiency and how to call the APIs, but there's also a really big state management problem here, because am I guessing that you have to keep track of the state of affairs? Like you said, you're getting versions of a file. You have one file, it's got 10 versions. What if you got 7 versions and then some rate limiting thing happened, or a crash or an error or whatever? You have to know and keep track somewhere of the state of affairs, that I was in the middle of getting this file and I only got 7 versions. I need to come back later. That can be the combinatorics of how big that could get is overwhelming. Do you keep a local state database, and how do you manage those long running state?
For a lot of things, we have like our task scheduling internally, so that you know what's up next and what you need to do and what you need to come back to. But aside from that, if there's a really hard crash and we are not retrying, for example, we'll surface it in reports so that at least the customer is aware of what went wrong, what worked, and everything, so that they can, okay, well, you can copy over again, or you can do an incremental copy and only copy what has changed or what is missing at the destinations in between. But that requires, yes, to store some, not a significant amount, at least some sort of metadata locally. We have our local database that we actually home built a few years ago, because we had some different challenges with the ones that were available back then, because we were doing a lot of reporting also, and then generating and refreshing reports was kind of very heavy on the disk, and that was about 10 years ago. So SSDs were there, but not everyone had them,
Mm-hmm.
So it was kind of hard on certain environments. But that system is quite complex itself. That I don't think we try not to change it too much. Let's say.
Yeah. That's funny that you mentioned that because the SSDs, you're right. Like we all take them for granted, but they haven't been around for 20 years. There's a lot of on-prem exchange machines that are still on spinning disks, spinning platters of metal. And people, I'm having a little moment here because I'm realizing that like earlier in career people who may only have 5 or 10 years in, have a performance expectation in their brains of an SSD, not just about it has better performance than an HDD, but also how it behaves when you ask it for 10,000 files on multiple threads and how asynchrony works, the relationship between the CPU and the IO. And you're going to have to think about both of those things as you move from the original world to the modern world.
Absolutely. But yeah, we're fortunate now to have access to a fast disk because there's too much just to bundle in memory, right? At some point, you have to make choices on, okay, well, this is going to slow me down a little bit, but to go faster later on. So it's been really it's really balancing. Like these scenarios are balancing. Okay, well, where's my should I focus on, be CPU bound, memory bound,
Right.
or network? And most of the time in our scenarios, it's network is the one that is kind of the biggest challenge because of rate limiting and such, where we don't have control over. But then again, the software itself is installed actually on customer machines, so they are the one who have the specs, who control the specs of the machine. We have recommendation of what you should have or expect. But then it's, we don't know. So we have to do a best effort of, okay, well, what people will have, what data, and what will be the impact of certain code paths.
And the bottleneck is the network at this point for most parts.
Yeah, most of the time.
I love my terminal. I have completely customized my terminal with open source tools like Oh My Posh. I love the Windows terminal. I've been talking about it for a long time. But recently, Warp has launched on Windows. This is a new way of thinking about the terminal, and I'm excited to see this newcomer into the Windows developer ecosystem. I think you should check it out. I definitely push back on a lot of sprinkling AI onto an application, but Warp is really recreating the command line. It's bringing AI and collaboration and a modern user interface to an essential tool. Historically, it's only been on Mac, but now Warp is bringing itself to Windows as a native application. It's a really, really interesting product. I spent a lot of time with the team, personally spending literally hours with them to help them improve their experience. They're really passionate about delivering a great product. I think the experience is really good, and it's a new take on the terminal. I think it adds a lot to the Windows developer experience. And if you maybe haven't been driving stick shift as much as I have, you haven't spent a lot of time at the terminal, and you want a terminal with a modern user interface that lets you talk to it in plain language, you should check out Warp. It's really, really interesting. And I've had a lot of fun running it on Windows. It's out now on Windows. You can get started for free at warp.dev/HanselMinutes. And as a listener, you get 50% off your first 2 months of Warp Pro with the code HanselMinutes, just all caps, HanselMinutes. And Pro gives you over 1,000 AI requests a month, which is certainly more than enough to do some damage. Very, very cool product. I encourage you to check out Warp, the intelligent terminal with AI. And I want to thank them for sponsoring Hansel Minutes. I don't bring a ton of sponsors on, and I certainly don't bring them on as guests, but I thought that this was a cool tool that you all should check out. That's warp.dev/Hansel Minutes.
Now, you had mentioned one thing I thought was interesting. With big files, you would not be able to go and take like a 50 gig video file, copy it over, hold it for a moment, and then copy it to the next side because you don't know where you're coming from and you don't know where you're going to. But maybe the APIs don't support chunking. How would you solve that problem?
There's few ways. So now we're fortunate because there are some APIs that are really for large upload sessions in Microsoft 365, where you can just start your session, then add some the next chunk and so on, and then close. So that is very useful for such big files. And before the limit of file size was a lot smaller a few years ago. It was at one point was 2 gigs, and it went, I think, 5, 10, 15, and then now it's, I don't even know, I think it's 50 or even more, I think. But back in the day, what we used to do, and what we still do often for smaller files, if you will, is really we're trying to stream directly from a source to a destination. So we just act as an intermediate of opening a stream, getting some bytes in the buffer, then pushing it to a destination, and then we can have something that actually works, so that we don't bundle everything in memory on the machine, and then you could only do a single file or two at the same time. At that point, you don't want this. You want to go fast. You want to do a lot of things. So since like that kind of usage is what allows us to go fast actually, and do more in parallel while not bottlenecking with the machine's specs.
Is there metadata that you like if you're moving from one system to another? Do you find a disconnect between, well, I'm moving from Google Drive to OneDrive, or I'm moving from Box to whatever, and I'm like, oh, well, this system doesn't support that bit of metadata, and how do you deal with those kind of mismatches?
As much as possible, when something makes sense to map to another, then we'll do it. Permissions might not be the same, but like the permission levels, let's say, between Google and Microsoft are not the same. But you have on both sides, you have something that corresponds to a read permission, a write permission, that kind of thing. Where, okay, well then we're gonna offer the ability for customers to actually map if they want to. Okay, well this is all in read, but now I want write at the destination. Well, then you can just go in the UI and map to a different permission if you want. But or if you have your own level of permission, but I don't think it's recommended anymore. That's a thing that can be done. But in general, sometimes you have to make trade-offs and accept that something won't be supported because of the difference. And then you have to set expectations, give proper visibility on customers that certain areas are not supported, either through our documentation or in the code. Sometimes we're able to detect those kind of things and give a warning saying, oh, okay, we're going to copy, but this will not be supported. Sorry about this. Or I remember when we did Google many years ago, Google Drive migration, and then there were symlinks, symbolic links. Okay, well, the same file is at multiple places. Which one do I copy and where? Do I want multiple copies of the destination? Probably not, because it's not the same. So then you had to choose, okay, well, we're going to copy it at a single place, and then give a warning and say, okay, well, just so you know, now the file is there. If you're not okay with it, move it elsewhere. But that's the idea.
So the company's been around a long time. You've been working on this for a long time. But then we mentioned Anthony, who we had on a while back, talking about Aspire. Aspire is new. How are you using Aspire in the company, and where do you see that kind of going forward? Because this is, you're adopting the latest technology as appropriate, but you're also using reliable technology. There's no reason to change what already works.
Well, we use it at certain places. For Migrate, we don't necessarily use it a lot because it's it's a WPF application. Most it's not a distributed application, I should say. But elsewhere in the organization, on other ShareGate products as well, or services and all, then we do. It's mostly for our like I said, our internal tooling to be able to run distributed application locally. We have some scaffolding solutions. We also have some tooling in terms of running sources with mock data, that kind of thing, and then running all in containers on your machine, and having to not have to deal too much with it, or run Visual Studio and then have 10 consoles running. We're trying to containerize most of it and script it so that you're able to get up and running faster. And this is where Aspire is our dashboard that we use for those efforts. And it's really it's really a great tool when you actually get to know it a little bit and start using it to have better visibility on your different services, everything that happens, all your logs, and not having, as I said, to dig through different consoles everywhere on your app and on your machine, and you don't know what is running where. So yeah, it's been great so far. Anthony is the one that brought it to us and really advocated for it, and for now, I'm hearing good feedback.
Yeah, I feel like Aspire is probably one of the coolest things that's happened in the .NET ecosystem in a while. I'm curious, what do you, I wonder sometimes why .NET and things like Aspire don't go outside the .NET community. Like, do you think that there's still people that are like, I don't want to use that, it's Microsoft, or I don't want to use that, I don't know what .NET is? Because I feel like Aspire is one of those things where if you show it to a container person, they're going to go, oh my goodness, that's amazing, this is fantastic, I should use this immediately.
Yeah, maybe people associate it too much with .NET, and I think there's been some good ongoing efforts with Microsoft diversifying and not keeping it at the Microsoft closed ecosystem.
Right.
There's more open source. There's more openness to running on on Linux instead or Unix or instead of Windows. That's been great for everyone at the end of the day. So. I think a lot of people could benefit from using those kind of tools more and more instead of, I don't think there's any gatekeeping or so. Like, it should be something that people leverage. I'm not familiar enough with other languages if they have something equivalent or as good as Aspire.
Well, it sounds like you're being very successful, that the folks at WorkLeap and ShareGate are building the tools that you need. Have you hit any limitations with .NET, performance limitations, or have you ever said, I want to do this, but I can't do it because C# is preventing me or .NET is preventing me? This is your thoughtful face. I can see you thinking.
Yeah, I don't think we have, like even with the volume of data that we're moving, the multi-threading, and especially in modern .NET, there's so much that was added in the last versions that I think it's just getting better and better. If I look at older code that's running on .NET Framework, well, of course there's some things that we had to do like homemade or rely on third parties and such, that if you would rebuild this in modern .NET in .NET 8, let's say, or those kind of versions, well, you wouldn't need to build this over again. I'm thinking dependency injection. I'm thinking the thread management, with all async await that's been around for a long time now, but people might not realize 10 years ago it wasn't really there, right?
Mm-hmm.
So that's the So I think everything we wanted to accomplish, we were able to accomplish either with homemade solutions that are not ideal, but they still answer the need, right?
Yeah. Well, it sounds like that you guys are having a lot of fun over there at ShareGate. Folks can check it out at sharegate.com and see both the migration product as well as Protect, which is basically on top of, once you've migrated everything, you want to make sure it's all secure, it's working well for everyone. And if you decide to start rolling out Copilot, you make sure that all that data that you migrated is ready to be indexed appropriately. Thanks so much for spending time with me today.
Yeah, that was great. Thank you.
We've been chatting with Louis Beaudoin, the principal software developer at ShareGate by WorkLeap. And this has been another episode of Hansel Minutes. And we'll see you again next week.